Hello, my name is Josh Reingold, and this is my Physics 2212 Lab 2 bar magnet. The purpose of this lab was to measure the distance dependence of the magnetic field due to a single bar magnet, and then simulate using a GlowScript code and compare it to the experimental results. The main principles of this lab were the Biot-Savart law, shown here, and the distance dependence, shown here. The key takeaways from this lab were that the magnitude of the magnetic field was inversely related to the distance. The measured off-axis field was about 6.57 times 10 to the negative fifth, and the simulated off-axis field was about 3.21 times 10 to the negative fifth. The justification for using the Biot-Savart law was that the bar magnet acts as a magnetic dipole, and some assumptions that were made in this experiment were that there are no external magnetic fields or environmental effects acting on the experiment. To initialize the experiment, the system was defined as the magnet and the phone. The surroundings were everything else, and the initial conditions were that the magnet was placed on the same axis as the magnetometer within the phone. The methodology used was that the magnetometer in the phone was located, and then the phone was moved until it reads a certain x value, and the distance is recorded, and then this process is repeated for R of 20, R of 70, R of 120, R of 170, and R of 220. All of this is marked down in an Excel spreadsheet and then plotted on the graph to the right. After this, the Earth's magnetic field was calculated and its impact was removed from the equation, therefore calculating the actual corrected values. This is an image of the code that was used for the GlowScript simulation portion of the lab. The resultant data of this lab was that the average R20 was about 0.27 meters, the average R70 was about 0.2 meters, the average R120 was about 0.16 meters, the average R170 was approximately 0.15 meters, and the average R220 was about 0.13 meters. This is a magnetic field diagram showing the dipole magnetic field of the bar magnet used in the experiment. The final result of this experiment was that the measured off-axis field was 6.57 times 10 to the negative fifth, and the simulated off-axis field was 3.21 times 10 to the negative fifth. The assumptions were that there was no external magnetic field or other impacts that affected the experiment. Some potential error in this experiment was the cause of external magnetic fields, some human error in measuring the data, or an imperfect table surface or magnetometer placement within the phone. What if the magnetic north wasn't accounted for? If the magnetic north wasn't accounted for, then the measured magnetic fields would change because they would be affected by the magnetic north. Both the x and the y components would be impacted, however the z component would remain unchanged as the phone was laying flat. What if the two magnets were used stuck end to end? If the two magnets were used stuck end to end, then the magnitude of the magnetic field would increase due to the stronger combined field, and the two magnets would essentially act as one larger, stronger magnet for the purposes of this experiment.